Einstein's original theory, or one of the theories that he was working with before 1915, at 1913 he came up with what's now called the Entwurf paper, the EntwurfMetric, and this is exactly the metric that he presented, with a flat space over here. And as a result of not having the spatial curvature, he came up with the wrong prediction for the bending of light. And had the expedition gone out earlier, they would have found that his theory was incorrect. When he finally added in spatial curvature in here, he ended up with the right amount of curvature. But this was, in fact, what he originally proposed. However, he didn't propose it for the reasons that I'm saying. He proposed it for very different reasons. The equivalence principle, with this I'll end. The equivalence principle shows that light will bend. You know, the elevator falling, if you shoot light from one side of the elevator to the other, and it's accelerating down. By the time it goes down, if the light has hit the other side, the elevator is over here. So the detector is now further down, so the light has seemingly bent. So you can come up with arguments showing that light is bent in gravity. If light is bent, when does light bend in light theory? When there's a diffraction, when there's a refraction coefficient, right? Which basically you can think of as the speed of light changing. The speed of light changes in a medium. And he came from special relativity, which we didn't use. In special relativity, you have ds squared is equal to c dt squared plus the spatial part. So he said the speed of light should vary, and that will give you refraction, and that will explain what happens in gravity. So you had c as a function of r, dt squared. And only later did he say, you know what, I want to keep the speed of light constant. Instead of having the speed of light changing, I'm just going to have some other function in here, which is the potential. Keep c the way it is, and like that, which is what we did. So we came up with the same arguments, but without using special relativity. Okay, thank you very much. I know the time is a little long.